Linear motion for Leaving Cert higher level physics. In addition to the ordinary level material you have covered, you may be asked to derive any of the 3 equations of motion in your exam. And here we have the 3 equations of motion. So I'm going to go through the derivation of each one. The important part is to commit to memory the starting point for each derivation, and then hopefully logic will bring you through to the end. So the first one is V equals U plus AT. So the starting point for this particular one is the definition of acceleration. So let's make a note of that. Starting point equals acceleration. So commit that to memory and let's see where we go from there. So what is acceleration? Acceleration is the change in velocity, so that's final velocity minus initial velocity over the time taken. So we're going to start with that. As you can see, it is very similar to what we want to be our final product, so we're just going to manipulate that equation and see what we can come up with. Okay, so I'm going to multiply both sides by t. Okay, and on the left hand side of that equation we'll get a times t is equal to, and on the right hand side we'll have v minus u over t multiplied by t, which of course will cancel. T divided by t is 1. So we have at equals v minus u. So we are very close to the finished product. We want v equals, so we will isolate that on one side of the equation by adding u to left and right. And we'll be left on the left hand side with positive u plus at equals to v, which of course gives me the final product. If I just flip left with right, we get v equals u plus at. Okay, so again, key point is to remember, commit to memory your starting point for each derivation. Let logic bring you through. Keep an eye on what you need your final equation to come out like, and just manipulate it to make it look like that. What you should do now is perhaps rewatch this derivation, take out a blank page, write down at the top v equals u plus at, and see can you start from the beginning and derive it. And after that is just repetition, repeat and repeat until you're pretty good with it. So our second equation of motion is s equal ut plus half at squared. You can guess there's a little more to this derivation, and the first thing to do is to see what is the starting point of this derivation, and this is something you need to remember. So this particular one, the starting point will be average velocity. Okay, so over a full journey, average velocity can be written as simply the total distance or displacement over the total time, which is s over t. Okay, or we may look at it in terms of an initial velocity and a final velocity and get their average. So that would be to add the initial velocity and add the final velocity and divide by 2, so mathematically getting an average. So we have 2 expressions here for the average velocity. So what we're going to do now is put them equal to each other or equate. So s over t should be the same as u plus v over 2. Okay, and now you can see that we have a lot of the elements we need in the final equation. We have s and t, the factor of 2. We have a u, but we do not need a v, and we need somehow to introduce the idea of acceleration a. Before we do that, however, I'm going to set it up so that we have s equals, and that requires multiplying by t on both sides. And so t divided by t is 1, and we get s equals u plus v multiplied by t over 2. Okay. Now, okay, there we go. Now let's compare to what we need. Okay, we have a lot of things. We don't have acceleration and we don't want the variable v. Okay, so from our previous derivation, we're going to recall, that means remember, that v is equal to u plus at. Okay, so there's acceleration being introduced, and we're going to replace v in our equation. So we're going to substitute for v. Alright, so now we'll have s equals, so inside the bracket we'll have u plus. Now instead of v we're going to write u plus at. So this goes down here. Okay, and that needs to be multiplied by t, and all of that should be divided by 2. Okay, so I think we're almost there. We're just going to tidy up and make it look like what it's supposed to. So let's look at the bracket first. Firstly, you have 2 u's inside it there. 2u plus at multiplied by t over 2. And let's multiply in that t. We get 2ut plus at squared to be divided by 2, and now we're going to divide each term separately by 2, so you'll get s equals 2 divided by 2 is 1, so just 1 ut plus, and we'll have at squared divided by 2, or if you prefer, or as is presented above, s equals ut plus a half at squared, and there we have it. Okay. Alright, so please pause, rewind, watch again, and then try it yourself from scratch on a blank piece of paper. Repeat and repeat again, and commit to memory the starting point, which is average velocity, and also perhaps put a star beside this part where you have to recall that piece of information. And finally, the third equation of motion that we're going to derive today is v squared equals u squared plus 2as. Okay, again, what's the starting point that I need to recall here? Okay, and we're going to start with actually the first equation of motion. So our starting point is going to be v equals u plus at. Okay, so we're going to use this, and we're going to use that to get an expression for v squared. So v squared will be equal to u plus at squared. So that's squaring the left and the right. Okay, v squared equals u squared plus half at squared. Next thing is to mathematically multiply that out. Okay, so you can take your time, multiply it by itself. You can use as much or as little rough work space as you require, but what you'll get when you multiply those brackets by each other is u squared plus 2uat plus a squared t squared. Okay, alright. Now, let's have a look at that. We have quite a bit of what we're going to need. We have v squared equals u squared, plus we have the factor of 2. Okay, so how are we going to work with this? How are we going to make it look like what we need to up here? Okay, and here's the next trick. Well, it's not a trick, but it's where we're aiming towards. Okay, we're going to try and find s. So introduce s, and if you remember from the second equation of motion, s is equal to ut plus a half at squared. Now you may see some similarities with what's up here. Okay, so the trick is to get ut here and here, I would have to take out 2a as a factor. Okay, so v squared equals u squared plus. I'm going to take 2a out of the second two terms as a factor. What does that mean? It means I'm dividing them by that. And the term I'm putting the star above here, when you divide it by 2a, now becomes ut plus, and if I divide the second term here where I have two stars, okay, if I divide that by 2a, well, dividing by 2 will give a factor of a half. Dividing by a, well, because it was originally a squared, there still remains an a in there, and we still would have t squared. Okay, now that bracket will now become s. Okay, so v squared equals u squared plus 2as, and that's what we wanted. Okay, so go back through that, rewind, replay, and try for yourself.